In chapter 13 part 3, we are going to cover the surface area of solids. Just remember in part 2 we covered the volume, so now we are going to continue with surface areas. So the surface area of a solid is actually the sum of the areas of each of its surfaces. And we have another term that we need to know, a net. A net is a plane figure that can be folded up to form a solid. So let's take a look at this example. Originally, we have a cube, 6-sided, and it can be opened up, okay, cut along the edges. You can open it up to form this figure, 2-dimensional, and this will be called the net. No, this is not the only net that you can obtain from opening up the cube. This is just one example of a net that is possible. Now, the next portion, in the previous section, meaning part 2 of the notes, we know that the perpendicular distance between the two bases of the prism is its height. Okay, we can call it the perpendicular height also. The other faces of the prisms, they are called the lateral faces. So as long as it is not the top and the bottom cross-sectional area, they are called lateral faces. Now in this case, the cube, it has 4 lateral faces as well as 2 cross-sectional areas. So for example, if I were to shade the bottom and the top as our base area, otherwise known as our uniform cross-sectional area, we see that there are 4 more faces that are not shaded. 1, and then at the back there's 1 on the right hand side, and at the front there are 4 lateral faces. So to find the surface area of a cube of length 2, we have 2 different methods that we'll introduce to you. First, we are going to find the cross-sectional area. Okay, you can choose the cross-sectional area in this case to be the bottom as well as the top. It doesn't matter in this case because it is a cube. Any face you choose, you have the same area. So cross-sectional area being 2 times 2 gives us 4 square centimeters. Okay, because all the dimensions in this case are in centimeters. Now the area of the lateral face, I give you one example of the lateral face. For example, the one on the right has an area of 2 times 2, that is 1 of it, and there are 4 of them. So we get a total of 16 square centimeters. Now we have covered one cross-sectional area, which is at the bottom. We have covered 4 lateral faces, and then the total surface area will be, you can copy down this formula, or you can derive it on your own based on the net, based on the diagram. So this will be our area of lateral faces plus 2 times of the cross-sectional area, otherwise known as the base area. Cross-sectional area. Why 2 times? Because one at the bottom that I shaded in blue and the other at the top. So we get a total of 16 plus 2 times of 4. Final answer, 24 square centimeters. That is the first method. The second method is by calculating the perimeter of the base. Okay, so let's start with the same diagram. Okay, I'm going to use the same base as the cross-sectional area, but this time we are going to find the perimeter. I'm going to outline the perimeter in red. Now this perimeter is 2 plus 2 plus 2 plus 2, which is 2 times of 4. Okay, and we get 8. What does the base look like? Okay, so it's just 2, 2, 2, and 2. It's a square. Now in part C, we're not done yet. Part C, it tells us to find the perimeter of the base, which we already found, times the height. Perimeter of the base and the height, in this case, this 2. What will that actually give us? numerically it is going to be 8 times 2, which is 16. What does this 16 square centimeters refer to? So if you imagine this red color outline, which is the perimeter of the base area, kind of looks like a rubber band, a squarish rubber band. We're gonna place an identical squarish rubber band on top of it. So we're gonna add another one. And now it has a height. I'm gonna add another piece. We're gonna keep adding all these squares all the way up to the top. For one of this rubber band, we have actually calculated the perimeter. And if we multiply it upwards by the height of 2, we have now obtained the total area of the lateral faces. Okay, in summary, from one perimeter, we multiply by 2, we end up calculating the lateral face at the front plus the lateral face at the side. Okay, so plus the lateral face at the side plus the lateral face at the back plus the lateral face at the side. This refers to the sum of area of lateral faces. All of them. So, the next portion says, what do you notice about the value in A part 2, which is 16 square centimeters, as well as the answer in part C, 16 square centimeters. They are the same. So what is the other way of finding the surface area using what we have just discovered? So surface area, instead of saying all these area of lateral faces, we now have a method of calculating it. It is known as the perimeter of base area. I'm writing base area instead of cross-sectional area because it's shorter. Okay, so the perimeter of the base area multiplied by the height, and we still need to add the 2 cross-sectional areas. So I'll just put it at the bottom. 2 cross, let's use base area. 2 times of the base area. So let's see what we end up with in this particular case. The perimeter, we found that it was 8, height was 2, and 2 times of the base area. So one base area was 4, and we end up with still 24 square centimeters. So watch this video over here and and understand how the total surface area of a prism can be calculated.